All right, well, welcome back, or thanks for staying for those of you who are still here. I'm really looking forward to this next session. I know we've covered a lot of ground so far, but this is something new for this track. And that's talking about PKI in a very different way. I mean, Chris in the last session talked about all the new ways that we're using PKI. Containerization and 5G are definitely two of those new ways, whether it's affecting the deployment of PKI or being used for those deployments. So without further ado, I want to welcome Ibrahim. He is the Senior Security Consultant at Rakuten. And I'll welcome Ellen Boehm, of course, who's our SVP of IoT Strategy at Keyfactor. Welcome and carry it away.
Thank you very much for the introduction, Ryan. So I have not the pointer here. This one, is it right? So we can switch. So yeah. So I will talk about the 5G, our 5G challenges, what we had. I will focus not, like I think there was also another 5G presentation. I will just focus a bit on the challenges like the RSA to ECDSA journey. And we have, what is not so often used is the containerized PKI. Basically, I will touch also containerized 5G PKI. And at the end, we will have a bit of automation and also Keyfactor command. So as you see here, part one is mainly containerized 5G PKI. And the 5G architecture, what we had a journey from RSA to ECDSA. We'll go deeply in a couple of minutes. Part two is mainly the automation in PKI and what we are doing in 5G and what we are doing in enterprise PKI, basically. So part one is eJBCA mainly, the 5G PKI switch over. So where is it used? I think maybe you know, may not, so therefore I will try to go over it. We are building 5G networks, not only in one country, in a couple of countries. The 5G network is built and we have a couple of PKI use cases. And we choose to make it containerized. As you know, there are different products of eJBCA like the appliance, like VNF solutions, on-prem, on cloud, but we have chosen our own on-prem with a containerized environment, which was pretty new even to any industry. So now, where do we need certificates? The basic question. So if we look into a 5G network, we are separating into three different places, which is the front hall, where we have mainly the remote units, the RUs, the base stations, which are near to the customers. Then we have a mid-hall, which is the DU, the CU, the distribute unit, or the centralized unit. It is also called as G Node B, E Node B, different terms in different specification. And we have the 5G or 4G backhaul, which is our core network. And of course, we are using certificates in all of those places, from RU to DU, from DU to CU, and from CU even back to the core network. So, and those are integrating differently certificate use cases, which we cover in the part two. So I just took, as we are in Spain and Barcelona, I just took the map of Spain, and we can see if we would bring up a greenfield new network into Spain, we need to have cell sites or base stations for 4G as well as for 5G in all over Spain. And then we have a network where we have our RAN, our base stations, where we can communicate or let customers communicate for internet or for phone. Of course, they are talking to our far edge DCs, which you can also call with the far edge and edge. This is the mid-haul. And the mid-haul, basically, the communication between them, there are small data centers. And those data centers between them also requires, they are just network functions, we can say, and they are deployed in a containerized manner, and they are talking to each other. The main goal is to go up to the central data center. So just to imagine, so we are in Barcelona. This is from CellMapper. This is an online tool. You can see 4G cells. These are coupled only from one vendor. So this is publicly available. You can also view it. Those are just 4G cells. You can see just the number of how many cells in sectors they have in Barcelona. And of course, you will have more in places where many people live. Just to have a picture of how many certificates we will look, I'm just trying to show that. So how many certificates are we requiring? As you see, the RUs, 4G and 5G and 4G, it depends really on how many sites and how big your network will be, and of course, what the customer requirements are. I just took rough numbers of sites. These are 20K for 4G, 20K for 5G. And roughly DUs and CUs, it depends on how big your network is. You will have thousands or hundreds of sites, which internally, if they are containerized, require more certificates in case of network function if they are containerized. So to have a rough number, only active certificates, you need up to 50K active certificates. So this PKI is mainly built to be 15, 20, or even up to 30 years. It depends on the regulations on the country you are building it. So 50 certificates in 30 years means like up to 2 million certificates for the network to maintain. So we will have at the end questions. So now I'm going over to the new containerized environment. This is like, you can take it as a blueprint. You can make modifications. You can put everything in one namespace. Those of you who know Kubernetes, they already know what is a pod, namespace, a service, and all the functions of it. I will just roughly touch it. As you see, we have the sites here. I just took the site, not the mid-hole. The same applies for the mid-hole. So you see, this is a PKI cluster. So out of different pods, you have a CA pod. What you can see in the middle, there's a CA namespace around it, and this is just a logical separation in a cluster. And you have, as a backend, you can use MariaDB, but you can also use PostgreSQL. As far as I know, EJBCA, on their managed services, they are also using MariaDB as a Galera cluster, which is HA, and therefore we chose also MariaDB as a backend. For sure, you need Kubernetes, persistent volume, and persistent volume claims to have your storage where all the certificates and all the configuration will be. And we have a CA, RA, and VA namespace for different services. So that means we are separating even in namespace based. So we have different services, and not everybody is going to reach for sure our CA, which should be secured differently than the RA and VA, since they will be reached by the radio units, by different use cases from all over the network. That's all about the PKI cluster. So we have 15 minutes. So I go to the next slide, which is containerized PKI, why we went for it. So it is not known, so it's not a default deployment. So why are we using containerized? So since nobody has tried it, we have a fully containerized environment on-prem. And of course, this is the industry standard with the change of DevOps mentality, with the automation, and the benefits what the containerized brings. So the first point is for sure the industry standard. We want to be fast and reliable for sure, and this we are doing with a DevSecOps mentality. So if you have pipelines, if you have the automation, and if you have DevOps overall in your company, you can make DevSecOps in your environment. So that means you're securing while the pipeline, your environment, and also your application. You can have more often upgrades and patches, and therefore we are going with a containerized environment. While in a VNF or in a virtualized environment, it would be quite different. Fast, reliable security deployments with Helm charts. So we are using the benefits of Helm charts. So we built in the beginning our own Helm charts. So, but now EJBCA has released also on GitHub. You can see also if you have the slides. In GitHub, there is a Helm chart for EJBCA, so you can reuse it and then customize it for your environments. It's very beneficial, and you have fast PKI in your own environment. Zero trust deployment, for sure automation was already mentioned. So zero trust deployment means, so we are even not trusting our own network, how we deploy it. Therefore, the benefits overall of all mentioned points gives us the zero trust deployment. It's not only for Helm charts and the containers and the cloud native deployment. For sure, there are a couple of other points as well. So I will go now, change the topic. Yeah.
Thank you. We're going to stay tethered. No, this is a little awkward. Hi. So just some perspective from my side. Again, as Ryan mentioned, I lead the IoT business at Keyfactor. So I get the opportunity to work with customers and partners across multiple industries. So telecom being one that we're talking about today, but medical devices, industrial. We talked about smart home yesterday, this morning as well as a use case. And it's very encouraging to see the adoption of PKI, certificate-based authentication, and similar architectures and frameworks as we're talking about here, independent of industry. So just as an introduction to this next section, I'm seeing more adoption of ECC certificates leveraged into these constrained devices that we are seeing in IoT because of the benefits of more, better randomness, better, the encryption algorithm obviously stronger, smaller size, I think 40% more efficient than RSA. It's better for battery power, that sort of thing. So this is real. I'm seeing it across multiple industries, but just want to kind of hear your perspective about how and why you guys have shifted to that as well.
Thank you for that. So we made an experience. Sorry, let me just take it. So we made the experience of changing from RSA to ECDSA. So, and it was it's a challenge if you do this overall, but if you have a time manner, so the challenge will, of course, double. So the challenge was to switch from RSA totally to ECDSA, and therefore we tried to build, and I just tried to map it here in 5 steps, what is done in very fast or in very short time. So the challenge is to build an inventory. So you need to know all applications, all requirements, all components. It is not only the 5G, for sure it is also the enterprise part. And I would even say the 5G is a big challenge due to the impact to customers. But the enterprise part is also a very big challenge due to different applications, and you need to collect all of the requirements and teaching the organization PKI overall. So for sure, the second point is the testing ECDSA certificates and giving guidances to people how to enroll, how to make it, because they know only commands from OpenSSL for RSA specific. Curl, for instance, has versions where you have, which are not supporting ECC overall, and those type of things you need to identify and do with a short time. It is getting a very difficult challenge. So why we did this? So it was regulatory demand. Second step, I just put inventory. 3 is ECC support. 4 is interim PKI. We will go one by one. And 5 is at the end the rollout of the PKI itself. So why we did this is because of I look every time into 2 regulations. One is the NIST, and secondly is the BSI. BSI recommends specific RSA only until 2024. There are a couple of them even up to after 2024, but you need to enforce TLS 1.3 or those specific signatures and key material of RSA. Therefore, we said if this is the requirement, we go and make it happen for TLS 1.2 and 1.3. So it's up to the application to choose which TLS version they want to use, because both are compliant. But still, we wanted to have one common PKI. More secure feature readiness, yes. So building an inventory is a challenge. As said, 5G PKI, it's clear, so it's a challenge. Why? Because you need to identify different vendors for RAN. If you have different vendors for your RUs, if you have different vendors for your mid-haul, then you need to identify with all the vendors that they are supporting it. If not, they need to put this into a roadmap. For sure, this will be a blocker for going live. You need to build an inventory with end entity, certificate specification, and their requirements. Supported key types. Some are supporting RSA and supporting ECDSA, which we identified through the journey. But some are having support for ECC keys and for ECDSA signatures. For sure, the amount of certificate is a big impact, because if it's only one application which can be delayed through the deployment, therefore the time impact, it has a lower priority from our perspective. But we need for sure a migration roadmap list. So that means if applications are not supporting those keys or signature types, then we need to have a timeline and therefore the inventory point as secondly. ECC support, what does it mean? So all the one who gave us the information, all the one we built with them the inventory, for sure, we need to support them to get this tested, verified, and make it production ready. So it's not only, okay, yes, we support, we need to see it working, because if you have no lab or pre-production environment where you test those certificates and see your PCAP, where you say, okay, the TLS encryption and the TLS cipher suites are supported, for sure this question will remain open. Writing guidances for them in order to make the version for OpenSSL, for CSR, writing guidances all over what they need. So I just put here is signing versus TLS cipher suite. What we had as a question in the beginning was, I mean, signing, it's possible. What we can see also in the next slide here. So this is just a rough two-tier CA. What you see, root CA is self-signed. You have an issuing or sub-CA, and then you have your leaf nodes, this ECDSA or RSA. RSA for sure I just put in red because we didn't want to see it. Which still is not being to be meant that it's totally removed. We just wanted to build an ECDSA network. So signing is possible. Where if you go with your issuing CA and sign RSA key, that's possible. It's fast. You can test it with OpenSSL, with eJBCA. We can test it with any tool. It is a fast test. But the TLS or the IPsec, if the tunnel comes up or not, the specification, so we need to test with different tools, with different applications that they can support ECC keys, or we need to identify them. Sometimes the application owners don't even know. And then in the lab, you go with all the applications, with IPsec vendors, with all your 5G software and vendors through that procedure of verifying if the TLS is being established or not. So therefore, signing is different than TLS cipher suites. So the fourth point should be an interim PKI. So it could be that you build in production an interim PKI next to your main PKI. What I, to be honest, I'm not suggesting to do. Why? It will make confusion. Everybody who builds trust in your own network, you need to establish that the trust is ensured. You need to make cross-sign, and it's making more complex, and you need to explain that's all the consumers of the PKI. And therefore, I would not suggest to go with that. So you can say, if anybody is not supporting ECDSA, you could go with RSA keys and the ECDSA, or you can go even with RSA keys and RSA signature, which for sure I would not suggest. So therefore, too much overhead, maintaining two PKI is the next, the operation, of course, consuming the consumers, confusing the consumers, and building trust would be the fourth challenge why I wouldn't suggest. Still, it could be done. Yeah, at the end is rollout. So you reached a very good point. You can enroll certificates, maintain an operation is then the main step. And for sure, you can do reporting with your Keyfactor command, which we will touch in the next slide. Maybe you can do also that. So lessons learned, I will just start. So many places for improvements for crypto agility. Yes, this is a point like we need to be agile because it was very fast, but the team, the application owners made come with us, so they also supported us. Automation is key because if we had the automation or more agile environments, which we are trying to build for sure, then it would be in future maybe much easier. Collaborative work means, I mean, also documentation. I can just put them both together. If you have no documentation, if you have no guidances, or the documents spread all over your organization, everybody is lost like a fish out of water, and then you have questions and pinging you directly. And this is just an overhead, so those are the lessons learned for that part. So just going then to part 2.
I'll introduce this one. Yeah, so the last topic here, in just a few minutes, is really around automation. And automation, to me, whether it's within the enterprise or within the IoT space, is really all about how do you set the right rules around when something should be renewed. And I think it's very important to have, especially when we're talking about issuing millions of certificates for unique identities, we have to be able to have a process to do that without human interaction, and to do that at scale so that we don't make errors. The duration of certificate timing it's decreasing, and if we have automation tools to be able to do that, I think it allows us to be able to be stronger and more secure. The other piece, and you kind of mentioned it, was around crypto agility, and we heard that this morning from David Hook, is just having the capability to be able to swap out our crypto when there is some sort of event and we need to do that. If you have thought ahead and sort of built this into the design and architected in a way to be able to update these identities, you as an organization are going to be able to respond more quickly. And again, from an IoT perspective, the customers that I work with are thinking about their end customers and the service that they're providing. So that's very important when it comes to quality, reliability, and maintaining that business.
Thank you for that. So automation in our 5G and for sure our enterprise. I will just touch it shortly. We have a couple of minutes. So as you may know, CMPv2 protocol is the protocol standardized by IETF, and this is mainly used also due to Open RAN compliance in 5G networks. And for sure, this is already automating everything, like updating the certificate, requesting the certificate, as you see here. You will have the renewal of the certificate, and the initial certificate you will get from the CMPv2 protocol, which is integrated to eGBCA mainly. So for sure, we need, in base stations, there is difference mentioned in the beginning. For base stations and for the mid-haul, there are different CMPv2 protocols used. Main usage for the base stations are the CMPv2 protocol with a vendor mode. So they have directly from the manufacturer, directly a certificate which is used for authentication towards our CA, and there we need to pre-register their root CA and trust their certificates in order that they can enroll with CMPv2 protocol their certificates. So there we have much automation already. This is the vendor mode, and we have a client mode for our containerized network functions, the CUs and DUs. And they are using it different. You can use a couple of different type of authentication methods towards the eGBCA. And there is an option, for instance, the shared secrets, where we choose to integrate this with a secret management tool due to if you have only a shared secret across your network, then it will increase the risk of everybody seeing, or anybody who's deploying those network functions, to see those secrets. Therefore, a secret management tool integration is much appreciated in this place, and this is what I would suggest for that part. Having only a couple of seconds, automation, why we are using Keyfactor Command and we are using Keyfactor Orchestrator. We need, our enterprise PKI requires automation, and this automation needs to have because some applications are not supporting any protocols, and those applications are automated with Keyfactor Orchestrator. So the problem overall, just having here, automating enrollment with protocols is one point. Either they need development efforts, or you are automating with Keyfactor Command, the enrollments, re-enrollments, key stores, and trust stores. So this is a very good point. Why? Just showing this picture. The orchestration is done mainly from a second tool, which is called Orchestrator in Keyfactor Command. And there you can integrate with different type of tools in your environment, where you can automate your re-enrollment of your certificates without integrating any protocol due to the development efforts. Last slide, I just put here F5 as a backup. So F5, if you have load balancer and doing TLS offloading in your environment on F5, then you have a central place for certificate renewal, trust store renewal, and the key store management. With that said, thank you very much for attending and listening.
Awesome. Yeah, thank you, Ibrahim. Thank you, guys. All right, so we have a little